All right, Calculus 2. Today, we're going to be taking a curve and we're going to be revolving it around either the X or Y axis, and we're going to find the surface area of the figure that we're done with. So before we get there, though, we're going to have to do a quick refresher with some algebra, a skill that we're going to use a lot during this. So here is actually, I'm going to write it up a little bit higher. Let's say that we have the square root of 2 plus x, and we're multiplying that by the square root of 1 plus x squared over 2 plus x. Okay, let's take a minute and make sure we can do this, because we're going to use this a lot, and I'm going to focus on this part right here. Well, what if we called that 2 plus x over 2 plus x? That's our 1. We're just going to rewrite it like that. So then we have plus x squared over 2 plus x. Okay, so what do we have here when we do this? So when we do this, this would be, on the top would be x squared plus x plus 2 over 2 plus x. And on the outside, whoops, all of that square rooted. And on the outside, we have the square root of 2 plus x. Okay, so it may not look like we've done a lot. We changed the 1 to a 2 plus x over 2 plus x so that we could combine the like terms on the top. Okay, so the next skill that we're going to need to do is we need to remember something. Do you remember how to simplify this? The square root of 16 over 9? That was pretty easy, right? That's just the square root of 16 over the square root of 9. That's just 4 over 3. So when we're doing something more complicated, it's going to be the same thing. And we're just going to rewrite this as the square root of the top over the square root of the bottom. Okay? Now we're really getting somewhere, because now we can cross off these. Those are going to cancel. And we see that in the end, this all is going to simplify down to x squared plus x plus 2. So this whole thing up top just is going to turn into this. Okay? All right, that's your algebra refresher. Now let's get going with this. So what we're going to have today, we're going to have a curve. Let's just make it a curve like this. All right, and we're going to revolve this around, let's say, the x-axis from, we'll just say 0 to 5. X is less than or equal to 0 is less than x is less than or equal to 5. We're going to rotate it over that. So from here to here, how are we going to do that? So we've got a curve that's rotating, and I know if we were finding the volume of this, we could just use either shells or washers, right? But right here, I'm not sure what to do. Let's do something easier. What if first, instead of this curve right here, what if we had just a nice straight line from 0 to 5? Okay? So question, what is that going to be? What shape is going to be produced when we rotate this around the x-axis? It's going to be a cone, right? This is going to be a cone. So if we want to find the area of this, the surface area of that line, it's going to make a cone, and we know that the surface area of a cone is 2 pi r L, where L is the slant height. Okay, whatever that is the slant height. So we can figure out the area of a cone really easily. 2 times pi times the radius times the length of that cone. But I'm sorry, times the, not the L, that's not the length, I'm sorry, that's the slant height. 2 times pi times r times L, the slant height. But what happens if that cone isn't made from a straight line, but is made from a curve? Something like that, for example. What happens if it's there? Well, now our slant height becomes a whole lot more difficult to figure out, doesn't it? We're still going to be basically working with that same formula, 2 pi RL, because it's still the idea of a cone, but that slant height is no longer easy to calculate. How are we going to do that? Well, the good news is we already know how to do that. We know how to find that slant height. We did it in the last section, except we didn't call it slant height. We called it an arc length, right? So we can do that. And we know that the formula for arc length is the integral of the square root of 1 plus dy dx squared dx. That's the arc length. So let's go back. We know that the area of a cone is 2 pi RL. And we now know that for a curve, our L, our slant height, is just the square root of 1 plus dy dx squared dx. And I bet you know by now, if we're going to find the area under a curve, we're going to have to use an integral. So right here, we see that we've actually found the formula for surface area of a curve that's rotated. All right, now let's get busy and let's use some of these. All right, so I'm going to work number 1 on your homework. Number 1 on your homework says that we are doing the line y equals x to the 4th. We're going to rotate that around the x-axis from 0 to 1. All right? Here's what I'm going to do just to save some space. I know that eventually we're going to have to come over here and find that 1 plus dy dx squared and take the square root of it. I'm just going to work that over here first and see to just keep things cleaner. So we know that y equals x to the 4th. That means dy equals 4x to the 3rd dx, and dy dx is just going to be 4x to the 3rd. Okay, so that's good. But let's go ahead and do this whole thing up there, 1 plus dy dx squared. So if I take dy dx squared plus 1, what is that going to be? Well, this is going to be 16x to the 6th plus 1. That's dy dx squared plus 1. So that's what we're going to put right there underneath that square root sign. So let's come over here and let's actually do that. So we're going to have the integral from 0 to 1 of 2 times pi times r times the square root of 16x to the 6th plus 1 dx. Now, just one more thing. We don't really want this r hanging out in there. Let's think about what this is. So we've got a curve that's basically looking like that we're going to rotate around the x-axis. So think about what the radius of that cone is. The radius of that cone is actually going to be the height that we see. So that's going to be the y value in this case. And what do we know that y is? Well, y is x to the 4th. So I'm just going to come back up here, and instead of r, I'm just going to write x to the 4th. So this is what we have for number 1, and again for number 2, we don't even have to evaluate, we just have to set it up. All right, so that's where we're gonna be. Let's see, next, let's skip on down to number 4. Oh, you know what, I'm sorry, I forgot to do part B of number 1. So that is part A. That is the first part. Now, Part B for number 1 says that we need to rotate this around the y-axis. Okay, so let's think about what this is going to look like. So we know we're going to have the integral of 2 pi r L. And what's that going to be? Well, here is the L. Here's the interesting part, okay? We sketched this. Let me put this sketch back in here of this curve. And we went from 0 to 1 last time. We're still going to use that same interval, but this time it's going to be around the y. So if I'm looking at the y, I know that y equals x to the 4th. So if I'm going over that same when x is 1, y is still going to be 1. So we're still here. We're still here going from 0 to 1. But let's talk about this arc length. Well, that arc length right there, whether I am rotating it over the x-axis or whether I'm rotating it over the y-axis, the cool thing is that arc length doesn't change. Whether I'm rotating it over the x or whether I'm rotating it over the y, the arc length doesn't change. So this L value, whether we're rotating around the x or the y, is actually going to be the exact same. So this is just going to be the square root of 16x to the 6th plus 1 dx. But this time, as we're looking at if we're rotating it around the y-axis like this, what is our radius going to be? Our radius this time is actually just going to be x. So this is all we have. All right? Okay, let's jump down to number, let's jump down to number 5. Number 5 is where we're going to actually start to evaluate some of these. Give me just a second. Catch your breath. These are going to get pretty tricky. We're going to have to really do some serious algebra with these, some serious calculus, and be really thinking. So this little break while I erase, you might appreciate that in a second. Okay, number 5 is y equals x to the 3rd. Y equals x to the 3rd. And we're going to rotate this around the x-axis from 0 to 2. Okay, first of all, let's figure out what all of that mess underneath this square root sign is going to be. So if y equals x to the 3rd, that means dy equals 3x squared dx, which means dy dx is equal to 3x squared. Okay, so now let's go ahead and square that and add 1. So if I square this and add 1 to that, that's going to be 9x to the 4th plus 1, and that's what's going in there. Okay, so let's go ahead and get this all set up. So we're going to have the integral from 0 to 2 of 2 pi r L, and L, our slant height, or in this case the arc length, is 9x to the 4th plus 1. Okay, let's do this. We have to sub something in for r. If we're rotating this around the x-axis, then our radius is going to be whatever our y value is. And in this case, we know that our y is x to the 3rd. So let's just put x to the 3rd in here and our dx out here. Okay, now how are we going to go about integrating this? Well, what I see is something that's perfect for a u substitution. Let's say that u is 9x to the 4th plus 1. That would make du 36x to the 3rd dx. And if we solve that for dx, du is 36x to the third, 36 over x to the third dx. Okay, let's come back and sub some of this stuff in. So we've got 2 pi x to the third times the square root of u times dx is now du over 36x to the third. Okay, let's simplify this. Our x to the thirds are just going to cancel. 2 over 36 is just going to be 1 over 18. And since that's a constant, I'm going to move that out front. 1 over 18. I think I'm going to take the pi out front also. So I'm going from 0 to 2, square root of u du. Okay, we can integrate this. That's no problem. That's u to the 1/2. So when we integrate this, this is going to be e to the 3/2, or u to the 3/2. Need our 2/3 out front. We're just going to evaluate this. Almost, and I probably should have done this last time. I'm going to write this wrong for just a second. 1 over 18 times pi times all of that. We're not really going from 0 to 2 anymore, because 0 and 2, those were your x values, and right now we're evaluating this in terms of u. So there'd be a couple ways we could sub u back in, or maybe we could just go back up to the top, and I'll put it in orange, and I'll just say when x is 0, when x is 2, what is u going to be? When x is 0, 0 to the 4th is 0, plus 1 is, so that's going to be u equals 1. And when x is 2, 2 to the 4th is 16. And 16 times 9, let me see, I think it's 144. 144 plus 1 is going to be 145. So that means u is going to be 145. So let's just come back down to the bottom here. And let's just put this in terms of u so we don't have to sub everything back in. U is 1 to 145. Okay, now before we do this, let's also move this 2/3 out here with that, with the 1 over 18. And this is just going to simplify to 1 over 27 pi, or just pi over 27. And then let's put this in. 145 to the 3/2, that is not going to come out very nice. So I'll just write 145 to the 3/2. And 1 to the 3/2. So we're going to go minus 1 to the 3/2, which is just minus 1. And so we can actually just leave it right there. If you want to simplify the 145 a little bit further, 145 to the 3/2, that's 145 root 145. So you could also have that there instead of the 145 to the 3/2. All right, so that's going to be our answer. Let's do another one. Let's do number 6. And bam, just like that, everything's disappeared and we're ready to go. How you like that? I figure you probably didn't want to watch me erase all of this stuff. So here is number 6. How are we gonna attack this? Well, again, I want to start by coming down and kind of figuring out what that 1 plus dy dx squared is going to be. So let's bring this down here. 9x squared equals y squared plus 18. It's not 9x squared, it's just 9x. Here's what I would really, really like to do. Since we're going to rotate this around the x-axis, I'd really like to know what my y value is going to be, because I'm going to need that for the radius, right? Because remember the formula, what we're looking for is 2 pi r L, which is our arc length there. So let's go ahead and just get this solved for y right away. So I'm going to subtract the 18 over and then take the square root of it. So this is going to be 9x minus 18 to the 1/2 power, square root, is equal to y. Okay, subtract the 18, take the square root of it. Okay, you've got it. Now let's take the derivative of these. All right, so this is going to be 1/2 times 9x minus 18, chain rule times 9 dx, and that's going to be equal to dy. Okay, so let's get this cleaned up just a little bit. Dy dx is going to be, whoops, and this was to the negative 1/2. Forgot to put that in there. 1 over 2, and 9x minus 18 to the negative 1/2 just means the square root of 9x minus 18, and that's going to be on the bottom. Okay, so what do we have to do from here? Well, from here, we're going to have to square this and add 1 to both sides. Square both sides and add 1. All right, so what is that going to be when it's squared? Let's put it all over here, keep it clean. 1 squared is going to be 1. 2 squared is going to be 4. And the square root squared is just going to leave us with 9x minus 18. We've got plus 1. And I see I made a mistake back here. I lost my 9 in this. So this really should have been a 9 halves on top. And so when I squared it, it was going to be 81. All right, let's come over and clean this area up just a little bit more. 9x minus 18 on the bottom. Let's factor a 9 out of that and just make this a 81. If I factor a 9 out of that, that's going to be a 36. And this is just going to be x minus 2 plus 1. Okay? All right, so we've got this. Now we can simplify this. 81 over 36. We can divide both of those by 9, right? And that's just going to be 9 over 4 times x minus 2 plus 1. Okay? All right. So what can we do with this? What if before we put that back in, we're just going to bring this over here and continue this. What is 9 over 4 times x minus 2 plus 1? Well, let's distribute that bottom and say that this is 4x minus 8. Okay? 4x minus 8 plus 1. And that plus 1, let's just call that 4x minus 8 over 4x minus 8. Okay, so are we getting anywhere here? Well, we can add these together now. So on the top, we're going to have 9 plus 4x minus 8 over 4x minus 8. And that is all going to lead us to be 4x plus 1 over 4x minus 8. Whew! We have done some work, haven't we? All right. Well, let's put this back in and see where we get. So let's see. We've got 2 pi RL, and RL, actually we're going to have to sub in our R first. What's our radius? Since we're going around the x-axis, our radius is our y value, and back there at the very beginning, we found out that our y value was 9x minus 18 to the 1/2 power. And our L that we just found was the square root of 4x plus 1 over 4x minus 8 dx. Okay. More serious algebra. Let's look at this. We can factor a 9 out of that, right? So let's say that this is going to be the square root of 9 times the square root of x minus 2, right? Because 9x minus 18 to the 1/2 power, that's just the square root of it. So if we factor the 9 out of that, we're going to have the square root of 9 times the square root of x minus 2. Times all of this. Okay. Let's come back and change this a little bit. What's the square root of 9? We know that is just 3, so let's just sub that in. And then let's clean all of this up and move all of that out front. Let's do that. So this is going to be 6 pi times the integral of the square root of x minus 2, the square root of 4x plus 1. And while I'm at it, I'm going to clean up the bottom there. 4x minus 8, let's factor out a 4 and just call this x minus 2. Okay, now dx. Now let's simplify this. So we're going to clean up the top of this, and that's just going to be the square root of 4x plus 1 on the top, and the square root of 4 times x minus 2 on the bottom. Okay, let's rewrite this a little bit. 6 pi 2 to 6 square root of x minus 2. We really are getting somewhere now. Square root of 4x plus 1. And on the bottom, we can bring out the 4 and just call this the square root of 4 times the square root of x minus 2 dx. And what's the square root of 4? Square root of 4 right here is just 2. Okay, well, we can factor out that 2 on the bottom, or the 1/2, and we can move it out front. So this is just going to be 3 pi, and we're really getting stuff. We're really getting close right now. Square root of x minus 2 times the square root of 4x plus 1 over square root of x minus 2 dx. Okay, now I'm going to have to clear this off the bottom so that we have some work. If we were in class, I'd be erasing my whiteboard right now. If I was working on paper, I would just rip this off, start new. Okay. All right, so what can we do? Well, the nice thing now, we have got some stuff that we can cancel. The x minus 2's, root x minus 2's are going to cancel. Okay, so let's keep writing in red because we're so close. I can feel it. 2 to 6, 4x plus 1 to the 1/2 power dx. Okay, we're close. We're so close. All right, let's integrate this. 3 pi. And then we're going to have in here, this is going to be 4x plus 1 to the negative 1/2 power. But we had to undo that chain rule. So that was a 2 from the negative 1/2. Wait a minute. Oh. So much going forward and backwards. I am forgetting this. You guys probably caught it. When I'm integrating that 1/2, that's not really going to negative 1/2. It's going to 3/2. So we've got a 2/3 out front. And then we've also got a 4, 1/4 to take care of that 4, that chain rule in there. And that's all going to go from 2 to 6. Okay, so I'm going to have to come back up and erase some of this up at the top, and we're going to just have to make some more room up here for what we're doing for our calculations. This is a beast of a problem, isn't it? Okay, that doesn't want to erase, so it can just stay there. All right, so let's move the 1/4 and the 2/3 out front. So when I move the 2/3 out with the pi, with the 3 pi, that's just going to end up being 2 pi. And 2 pi times 1/4 is just going to be 1/2 pi, or pi over 2. All right, and then what do we have? 4x plus 1 to the 3/2 power going from 2 to 6. Okay, let's see what this is going to be. When I put 2 in here, that's going to be 8 plus 1 is 9 to the 3/2 power. That's going to be pretty nice. That's going to be 27. Am I right? It's going to be 27 pi over 2 times 27. And then, whoops, I'm sorry. I put that in wrong. That's going to be a minus 27, isn't it? Because I got to do the 6 first. So this is going to be 25. I'm sorry, 6 times 4. When I sub in the 6 in for the x, I'm getting tongue-tied right here. 4 times 6 is 24, plus 1 is 25. To the 3/2 power is going to be 125. So we're going to have 125 minus 27, and that is going to be 98. So we've got 98. All of that was 98. So pi over 2 times 98 is going to be 49 pi. And after all of that, that is our final answer. Okay? At this point, you know all of the mechanics that you're going to need. These problems are going to get tough, but you understand it at this point. Remember, we start with a cone, 2 pi RL, and L, if it's straight, that's easy. That's just a cone, but we're using curves now, and that L, that slant height, is just arc length, which is square root of 1, the integral of the square root of 1 plus dy dx squared, right? So put those all together, and we've got it. Make sure you're being cognizant of which way you're rotating these, whether it's over the x-axis or the y-axis, so we know what the radius should be. And remember, regardless of whether you're going over the x or the y-axis, that slant height is going to be the same. All right? Not easy, but I know you got it. Good luck.